This question is asking for you to approximate the value of a double integral. The surface is x plus y, and the region that you are interested in having your double integral be over, R, is the circle x squared plus y squared equals to 16. So centered at the origin, radius of 4, but only the positive part, the upper half of that circle. So we have the upper half of that circle. It's a semicircle, and it's bounded below by the x-axis. And then it's a very particular way they want you to partition the x-axis and the y-axis. So we partition at x equal -4, -2, 0, 1, 2, and 4. And then we partition at 0, 2, and 4 when it comes to y. And so we chop up the interval. We chop up the region into these sub-rectangles, but we're only interested in the sub-rectangle that lies within our region. Only the sub-rectangles that lie within the region. And so what's going to happen is basically we're going to get these, the following drawing. So with that many subdivisions in x and that many subdivisions in y, we should have 10 different rectangles. There's 5 subdivisions in x and 2 subdivisions in y. But with these 10 different rectangles, 7 of them will not apply because they don't lie entirely within the region R. The ones that are shaded in purple here lie entirely within the region R. So this is rectangle 1, this guy is rectangle 2, and this guy is rectangle 3. Now imagine this is the floor. Your surface is the plane z equals x plus y. And so to get the rectangular prism, we have to take the area of the base and multiply it by the height of that rectangle. They tell us to get the height of the rectangle by using the lower left corner for your evaluation point of each of these rectangles. And so lower left corner would be here. So the lower left corner will be here on the x-axis for rectangle 1, where x is -2 and y is 0. The lower left corner will be here for rectangle 2, and that's going to be the origin. And the lower left corner will be here for rectangle 3, and that's with 1 for x and 0 for y. What we do with those is we plug them in. So we have our points of evaluation, and we plug them in. -2, 0, get plugged into the function, which is just you adding these two together, x plus y. And so we get a -2, we get a 0, and then we get a 1. That's the function height. And then the function height gets multiplied by the base area. You know, it is a rectangular prism. You do the area of the base times the height. So we got to find the area of R1. That is a 2 by 2 rectangle, so we get 4. The area for R2 is a 1 by 2 rectangle, so we get 2, and so is R3. And so for the volume of these guys, we take these base areas and we multiply by the function height, and that'll give us the volume. And we sum these volumes. So we get a -8, we get a 0, we get a 2, and we sum these rectangular prism volumes, and it actually ends up as a -6. The function dips below the x-axis, and that's why we have this negative volume. This is an approximation. It's definitely not anywhere near the exact answer, but they added the extra part where we had this circle and we only wanted the full rectangles that were inside the circle, so we got to throw out 7 of these rectangles. This isn't the standard way that we do approximations, but this is just to show you when your region is not rectangular and you still want to do an approximation, this is kind of what you have to deal with. If you have any questions, please comment down below or email me.